Hi class, so this video is going to be short and it's going to go over section 7.3, which is titled Assessing Normality. So I have here written, so up to this point we have said that a random variable x is normally distributed, or at least approximately normal, provided the histogram of the data is symmetrical and bell-shaped, right? And we looked at this in the last section, right, where we were given a histogram of data and trying to see if it looked to be bell-shaped. Right, so this works well if we have a large data set, but if we have a small sample, that's not always the best way to see if the population, if the sample looks to come from a population that is normally distributed, right? So for this reason, we're going to look at an additional method for assessing normality of a random variable x when we're looking at a small set of sample data, right? So to be able to do this, we need to look at what's called a normal probability plot, right? So this is a graph that plots the observed data versus what we call the normal scores. So a normal score is the expected z-score of the data value, assuming that the distribution of the random variable is normal, right? What we would expect to happen, right? So I have here, this is from the text, the steps for calculating these, and there's a worked out example of the calculation. So if you're interested in learning more about that calculation, feel free to look at that example in the textbook, but I'm not going to expect you to do this. What I want you to be able to do from this section is be able to use StatCrunch to create a normal probability plot, and then determine if something looks to be normally distributed or not, right? So when we look at this normal probability plot, what we're going to be looking for, right? So it says if the sample data are taken from a population that is normally distributed, a normal probability plot of the observed value versus the expected z-scores will be approximately linear, right? So when we make this plot, when we plot the plot the data values versus the normal scores, that should line up in a straight line, right? So we're going to use some information that we learned in chapter 4 about linear regression, right? So remember, we have this table from chapter 4 of critical values where we looked up the sample size and then the critical value. And remember, if your correlation coefficient is bigger than this critical value, right? So when you get a linear scatter plot, right, we can calculate the linear correlation coefficient R, right? So remember, if R is bigger than this critical value, right, from the table, then it's linear, right? We can conclude that it looks to be a linear model. But remember, if R is less than the critical value from the table, then it's maybe nonlinear, right? So we'll use this table that we use, table 6 from the book, to look at this, right? So I have some examples. So example 1, we have a random sample of 20 undergraduate students receiving student loans that was obtained, and the amount of their loans for the 2018-19 school year was recorded. We want to use this data set that's titled 7_3_9.csv on Canvas and use a normal probability plot to assess whether the sample data came from a population that is normally distributed, right? So in this case, since we have 20 undergraduate students, my n value equals 20. So if I look up at the table, the critical value for n equals 20 is 0.95, right? So the critical value equals 0.951. So what I need to do is create this normal probability plot and find out what R is, right? The correlation coefficient. So I'm going to open up StatCrunch. Right, so I have the Excel file posted under datasets and modules, or we can go here to go to datasets from your textbook and find it this way as well. right? So it's in chapter 7 and 739, right? This problem, right? So in order to get the normal probability plot, right, you're going to go to graph and then go to where it says QQ plot. Right? So then you'll select the variable here, and then you got to check two boxes. We're going to add the correlation statistic, and then also this normal quantiles on the y-axis, check that box, right? So just select the variable, check those two boxes, and then hit compute, and then we get this graph. So here, here's the data, right, graphed, and the correlation coefficient is up here, which is 0.88, right? And that red line, that's the fitted equation, right? The line of best fit from that data, right? So this correlation coefficient is 0.88, right? So R was 0.88. So since this is less than the critical value of 0.951, then this is not normal, right? So it doesn't look like that sample came from a population that's normally distributed, right? Right, so that's all there is to that. So let's try another one here. So example 2 is similar, except we're looking at a random sample of O-rings that was obtained, and the wall thickness in inches of each was recorded. Right? So if you don't know, what an O-ring is, right? It's something used, you can buy like at a hardware store, right? It's like a plastic ring, right? So that's what we're talking about. It's like used for a seal, right? So we have a random sample of these O-rings, and we want to see if their wall thickness looks to be normally distributed, right? So again, you'll want to use StatCrunch for this. Right, so this was 737, right, that data set. You're going to go to graph, and then QQ plot, and then hit the variable, check these two boxes, hit compute, and we get that graph, right? So we get the correlation coefficient, which is 0.979, right? So if I record this here, right, my correlation, so well, first it didn't tell us the n value, so let's look for that. Right, so you can kind of see that this would be 20 because the rows start up with number 1, and that lines up with the first data set, and it goes up to 20. Right, you could see it that way, or if you go to summary stats, and go to columns and hit the variable you want, you could click on just n here and hit compute, and that tells you how many things are in your data. Right, either way, especially if it's maybe too long to look or count. Right, so n equals 20. If we look at the table for n equals 20, we have the same critical value. So the critical value was 0.951 still. Right, so it's the same thing as the last problem because we both have the same sample size. And then the correlation coefficient value that we got from the QQ plot, right, that was 0.979. Right, so R was 0.979. So that is bigger than the critical value of 0.951, right? So this looks to come from a normal, from a population that's normally distributed, right? So that's what it looks like if it's normally distributed. So then example 3, we're told that a random sample of college students aged 18 to 24 was obtained, and the number of hours of television watched in a typical week was recorded. Use the data set 73_12 on Canvas, right? So first, part A says draw a normal probability plot to determine if the data could have come from a distribution, from a normal distribution, right? So let's check that out. So we'll go back to StatCrunch, right? This is 7312 data set. My n value here is 25, right? There's 25 things in the data. So n equals 25. The critical value, right, from the table for 25 is here. So 0.959. Right? And then so now we need to calculate the correlation coefficient. So if I go to graph and then QQ plot, right, select my variable, check these two boxes, hit compute, and we get the normal probability plot, right? So this looks to be linear, right? The correlation is 0.992. So if I go back to this, I found R equals 0.992, and that's bigger than 0.959, right? The critical value. So this would be normal, right? So it looks to come from a normal distribution. So then now in part B, it says determine the mean standard deviation of the sample data, right? So I can go back to StatCrunch. I'm going to click on stat, and then summary stats, and then column, and then click on the variable, and we want the mean and the standard deviation, so I can select both of those, hit compute, and we have those values there. Right, so I'm going to round to 2 decimal places. Right, so the mean's 20.90, and the standard deviation would be 10.52. Right, so let me record that. Right, so x bar, the sample mean, was 20.90, and s, the sample standard deviation, was 10.52. So now in part C, it says to use the sample mean and standard deviation obtained in part B as estimates for the population mean and population standard deviation respectively. Draw a graph of the normal model for the distribution of weekly hours of television watched. Right? So basically what we're saying is that x bar is going to be approximately equal to the mean, and s is going to be approximately equal to the population standard deviation. Right? So we're going to use these values for the population mean and standard deviation to create a graph of the normal model, right? So we can start by drawing my axis, right? Drawing the bell-shaped curve, right? Right in the center is going to be the mean, which is 20.9. And then I'm going to add and subtract the standard deviation going both ways. Right? And remember, typically we're going to go three tick marks to the right and 3 to the left. Right? So if I take 20.9 plus 10.52, I get 31.42. And then add 10.52 again, I get 41.94. And then add that again, I get 52.46. Right? And then going the other way, we're going to subtract 10.52, right? So we get 10.38, and then negative 0.14, and then negative 10.66. Right? So then part D says using the normal model from part C, right? So that was where the mean was equal to 20.9 and the standard deviation was equal to 10.52. right? We want to find the probability that a college student age 18 to 24 selected at random watched between 20 and 35 hours of television each week, right? So in other words, if I draw my picture here, I'm going to have this normal model, and in the center is going to be the mean, 20.9. I'm looking between 20 and 35, trying to calculate this area, right? That area is going to be equal to the probability that x is in between 20 and 35. Right? So remember, we use StatCrunch to calculate that area. Right? So I'm going to go to stat calculator and then go down to normal and fill in. So first I need to hit the between button, right? We're finding probability in between two values. My mean is 20.9 and my standard deviation is 10.52. And then so I want to calculate this in between 20 and 35. Right? Hit compute, and there's my probability, right? The area. There's my nice graph. So the probability that x is in between 20 and 35 is equal to 0.4440 if I round to 4 decimal spots, right? So then in part E, it says use the normal model from part C to determine the proportion of college students aged 18 to 24 years who watch more than 40 hours of television each week, right? So I would draw my normal model. In the center is the mean of 20.9, and then over here is going to be 40. And we're trying to find the area to the right of 40, right? Larger than 40. So in other words, what's the probability that x is greater than or equal to 40? Right? So I can calculate that using StatCrunch again. So go back to StatCrunch. I need to change this back to the standard calculator. My mean standard deviation is the same, right? Change this to greater than, and then type in 40, right? Greater than 40. Hit compute, and I get the area there, right? That's the probability and also the proportion of students in that category, right? So this would be equal to 0.0347. I round to 4 decimal spots, right? Because remember, that area represents the probability of selecting, randomly selecting someone in that category, in that group, right? Then it's also equal to the proportion of people in the population that fit that characteristic, right? So in parts D and E, we just looked at wording those differently, right? In D, we were doing the probability, where E, looking for the proportion of people in that category. So that was, if you remember from the last section, there were 2 bullet points, and we used that to interpret that area in 2 different ways. Right? All right, so I promised this would be a fairly short video. That's all I want you to be able to do from this section. Let me know if you have any questions. Thanks.